All right. Thanks for tuning into our TC Lab cooling fan project report. Um, we're really excited to share with you what we've been working on and what we were able to accomplish. So, as we know, we've been working with the TC Lab throughout this semester, been doing lots of different assignments and projects with it, and we decided to alter our TC Lab to include a fan instead of the second heater that we can adjust accordingly to keep the set point temperature exactly at what we want it to. So, like I mentioned, the goal ultimately is to maintain our TC Lab heating element at a specific set point temperature by using a cooling fan. Um, and we're able to accomplish that by removing the second heater and placing a fan there instead and connecting it to its pin. So, the idea of this is to mimic thermal management systems, things like computer component systems, where you have anything that heats up over time. And we wanted to simulate, well, how can we control the fan to make it run at different speeds and keep our temperature at a specific point, despite whatever the heater may be set to. So the heater power is going to be our disturbance variable throughout this project, and the fan power was a manipulated variable and what we were changing throughout the process.
So here you can see the setup that we ended up going with for our TC lab. As Wade mentioned, you'll notice that one of the heating elements was removed. That's so that we could use the pins for that output to actually control the response of the fan. So we removed that heating element and we hot glued the fan onto there. And then with a breadboard and just a regular 12-volt power supply, we were able to regulate the voltage to the fan to make sure that it was receiving the appropriate amount of power needed to cool the heating element off based on the temperature set point. And we also made sure that the fan was at a proper distance and angle just so that the pass of the breeze and everything like that would properly cool the fan or properly cool the heating element off. So this was the final setup that we ended up using.
Yeah, and then as a starting point to get our PID controller moving, we performed a step test. And using that step test data, we were able to regress the parameter for forced convection and that energy balance for the TC lab. And that energy balance is enough for us to have a physics-based model. And so implementing that physics-based model into Streamlit is able to create a model that lets you change the PID values for KC, tau I and tau D, and then see how our system performs. And that gave us a great starting point for what to try on our actual PID.
Yeah, so as we can see here, after we got those initial guesses from our models, we decided to put it to test on the hardware, and this was the response that we got after some more tuning of the parameters. We found that the most optimal response was a KC value of negative 1.19 and a tau I value of 8.8 seconds. And as you can see, there is a couple of overshoot, but then after it shoots past the set point just by a couple of degrees, that fan was able to cool it down properly right back down to the set point. And throughout this test, we had multiple changes of the set point as well as the disturbance variable where the heater was changing values, trying to account for running a computer at different processing speeds or different needs, and our system was able to handle it pretty well. Ultimately, we decided to go with just a PI controller and leave out tau D, which is why we found it to be a value of 0 seconds.
Overall, our project ended up being very successful as we were successfully able to maintain that temperature within a degree and a half of the set point. And the heater set to 100% power, even full power, we were still able to get it down to pretty much any temperature we wanted.
This also goes to show it proves that a system like this could be used for something in a real world application, like a computer component, like a GPU or CPU or something like that, or even other electrical industry, maybe data centers or something like that. We have seen that with the PI controller response, there might be potential for energy savings or cost savings just with the appropriate response of the controller. So that is what we found.
Great. Thanks for listening.